All right, good morning, everybody. I'm going to go ahead and get us rolling. I know there's a lot of good conversation happening. I'm glad to hear that, and hope that continues throughout the day today. But I want to go ahead and make sure that we're staying on schedule for our program. There's a lot of stuff that we have in store for you today. We're going to start off here with a little bit of a welcome to introduce you to Sentinel, for those of you that are new to Sentinel Ag and potentially working with us. We're also going to go from there into nitrogen agronomy. So you're going to hear a little bit from our agronomy advisor, Bob Gunzenhauser. You're also going to hear a little bit about irrigation agronomy this morning, and then hear from growers and how they're managing in-season nitrogen management. So that's what we've got on the schedule for this morning. Then we'll get into lunch, a keynote that's going to be delivered by Jake Linneman from AgSpire. And then we'll get into a performance review after that, and our final industry panel to really talk about those tools and products that are available to help you with in-season nitrogen management. Today is really all about gathering folks that are committed to the future of nitrogen stewardship, specifically doing that through data-driven in-season management. And it's also committed to water stewardship as well, as we've brought in irrigation to the platform. And I hope that you'll see that reflected throughout the day. We have the support of several different sponsors who are here today, and I want to highlight them because these sponsors are supporting the mission of agile agronomy. They're supporting the mission of better nitrogen and water stewardship. The first one I want to recognize is Goanna Ag. They're one of our Guardian level sponsors. They provide irrigation insights, their soil moisture probes, and crop canopy temperature sensors. Derek Brazda from Goanna is here today. They do have a table over there on the side. All of our exhibitors will have tables over in the east part of the main room here, so I do encourage you to go and visit them at breaks. Tidal Grow Agriscience is another one of our sponsors. They're going to be here later today. Trey Cutts will be speaking on a panel, so you'll get a chance to hear about their novel nitrogen delivery technology that they have for foliar feeding of nitrogen. We have Farmation, who's also a Guardian level sponsor, and they have a table set up over there in the east part of the room. They provide technology to help monitor fertigation and chemigation events, and actually provide data that shows that those events are working as they should be. So I highly encourage you all to go and check out Farmation. We also have several recon level sponsors. We have Land Option, Region Ag Lab, who is not able to be here today but wanted to support the mission that we're on for better nitrogen stewardship. We have Egbert Service, who provides irrigation, telemetry, and control services. And then Redox Bionutrients has also supported our event today in the pursuit of better nitrogen stewardship. So thank you to all those sponsors. They're really, they're part of what allows us to really make this a great event for everybody that's in attendance today. A few housekeeping notes. There are several different opportunities to connect with Sentinel during the event today. Number one, I want to highlight our product feedback table. So if you go out into the pre-event space, so into the foyer there, you'll see a table directly back behind these doors on the right side that has a computer monitor up on it, and it's going to have our app sitting on it as well. One of our engineers will be sitting at that table all day today. So if you have questions about the product, you want to sit down and take a look at it, you want to provide feedback from your experience over the last year, please go and sit down with them, have a one-on-one conversation. We move that table outside of the room so that you can have all the freedom to talk about whatever you'd like out there and not feel like you have to be hushed in here as there are speakers presenting. So I really encourage you to go take advantage of that. Right next to that table, outside, we have an enrollment table. So for anybody that wants help getting fields into the platform, wants to learn more about what it takes to get signed up, I would highly encourage you to go visit that table. We'll have one of our account managers there throughout the day today to make sure that they can answer your questions. And we also have a collateral table, so you'll see that out there, that we have a table where you can go and pick up different materials if you'd like to take anything with you to continue reading after your time here today. We do have CEUs available for Sentry Network Summit 2026, so if any of you are CCAs, there are 7 CEUs that are available for you. We have 3 nutrient management, 2 soil and water management, 1 crop management, and 1 professional development CEUs, so please take advantage of those if you are a CCA. Lastly, before I get into the meat of the welcome presentation, I really want to give a big thank you to the Scott Conference Center staff. We are in the Scott Conference Center right now. They've done a really good job of setting this venue up for us, and they do a great job for us every year that we do it here. So I want to give a big thank you to them. I also want to recognize our Sentinel team, and I'm going to start by recognizing Dylan Addington. He's our head of operations. He really helped to coordinate this event and make sure that it was a really successful event. And I also want to call out Jamie Stansel, my wife, who's our marketing specialist. She also helped to coordinate this event. So those two are who you can thank for this being a successful event. And if you don't think it's a successful event, blame me, because I'm the one that has the ideas and they just have to go execute on it. So if there are any bad ideas, those are all on me. I also want to recognize Chandler Folkerts. He's our VP of Engineering. Riley Elwanger is our Senior Software Engineer. James Herrick is our VP of Customer Success. Colton Salm is our West Region Account Manager. Jack Tickner is our East Region Account Manager. And we have Bob Gunzenhauser, our Agronomy Advisor, here today. We have John Castle, who's our Strategic Development Advisor. John Broody, who's a partnership developer for us. We have also a couple of interns, Kurt Schneider and Josh Hansen, on our team. Kurt is here this morning. Josh wasn't able to make it. He's a student at Iowa State, so but he's interning with us throughout the year, and he's been great to have on our team. So that's the Sentinel team. You'll see us floating around. I highly encourage you to talk to any of those individuals. We will have mics that are available for questions. So if there are questions throughout the day, just raise your hand and we'll get a mic to you as fast as we can. But yeah, without further ado, I'll get into the rest of the presentation here. So when we're talking about nitrogen right now, the way that I'm describing this is it's a wicked wager, right? We're dealing with extremely high nitrogen prices. The latest I'm seeing is about 70 cents per pound for liquid nitrogen fertilizer. So that's really out of whack with crop prices. Historically, these ratios have been basically a 10-to-1 crop price to nitrogen price ratio. Right now we're sitting at about a 6 to 7-to-1, so there's a lot of pricing pressure on nitrogen. Farm profitability is going to be key to longevity for farms. We're pretty confident in that. We're already starting to see that be the case. And we're also seeing that there is a lot of policy conversation about water quality and what might happen there due to health issues and some of the expenses that we're incurring to remediate water in rural municipalities. In the background of this is complex agronomy, right? So nitrogen is extremely difficult to manage. It is one of these nutrients that is highly mobile. It moves basically like water does in the soil profile. It's also difficult because yield potential is a moving target. Every single year you have a little bit of different yield potential. You may be planting a different hybrid, ends up out there in the field on a different date than what you may have expected. So your yield potential is going to move year to year, and that makes it really hard to chase. You're kind of chasing your tail with nitrogen management in a lot of ways if you're trying to be purely predictive with that. There are also insufficient solutions out there on the market today. What we believe with the market research that we've done is there's about $32 per acre left on the table on average with misaligned nitrogen rates going out on crops. And the current approaches really are not well suited to adapt to seasonal variability, and that is a problem that we really seek to solve at Sentinel. The bottom line is the cost of getting nitrogen wrong has really never been higher, and I think nitrogen is going to be one of the key things to manage in 2026 for farms to be successful. For those of you that are not familiar with Sentinel, I just want to give a brief story of our origins. We were founded in September of 2021 based on research that came out of the University of Nebraska-Lincoln, and we've been really focused on turning that research into applied results through our business. We started in fertigation scheduling, so using multispectral imagery at that time from drones to help inform when nitrogen should be applied to a crop via fertigation. That work was funded by the Nebraska Corn Board and the Dougherty Water for Food Institute, and we built the technology through on-farm trials. So we actually got feedback from growers and eventually built in time as a prototype software on a desktop that you all know today as a feature within our platform. We have since been able to deploy this technology in the field. We have iterated on it. We have seen it proven out commercially and implemented with commercial equipment. And now we are basically building out equivalent capabilities within broader irrigated and rain-fed systems. So moving beyond fertigation to be able to address all nitrogen application scenarios. Over the past several years, we've had a really significant impact. So when we look at our data that we've been able to collect commercially since 2022, that was our first growing season in business, the data that we've collected on our commercial fields, if you scale across all of our acres, has led us to these numbers that you see today. We believe that we have prevented 6.4 million pounds of unnecessary nitrogen application from being applied. So that's a very significant impact on overall nitrogen that's going out in the environment that likely wouldn't have been used or could have been susceptible to risk. We've put $4.9 million back into farmers' pockets. That's what we believe based on the profitability numbers that we have collected commercially. And if you were to convert that into a volumetric water benefit, which is a really hot topic within kind of the data center world and people that are talking about water quality and quantity, that's about 698 billion gallons of water that has been remediated by better water quality, right? So this is a very significant impact. This is just in 4 growing seasons of doing this, and not even at the scale that we would like to do this quite yet. So there's a very significant impact, and you are all part of this impact actually happening. Something that came up during our registration process that kind of got me thinking even more about this impact is we actually had one of our registrants who asked if we could possibly project out what improvements in NUE would do to global supply and demand for nitrogen. So I want y'all to kind of take a little bit of a ride with me on this. This is all completely hypothetical, but I thought it was a very interesting question to really think about what is the potential impact of improving nitrogen use efficiency. Right now, the data that we have suggests that a 1 NUE is kind of an international baseline for nitrogen use efficiency. That's probably a little bit even more efficient, I think, than reality, but I think it's a good baseline to start with, suggesting that we're applying essentially 1 pound of nitrogen per bushel of grain produced. If you were to look at moving our NUE values across the board for all globally produced crops, if we're looking at corn only initially, we believe that in year 0, right, so this is if we have static yields and we're staying the same, we're not improving yield, we're not decreasing yield, what we would actually see is about a 10 million ton reduction in nitrogen demand, right? So this would be a huge impact on the global supply chain for nitrogen demand. If you were to project that out over consistent years, given that yield is not changing, that's going to stay about the same. If you extrapolated this out to all non-corn or all non-legume crops, I should say, so corn, other cereal grains, cotton, things like that, you would actually see a dramatic reduction in that total nitrogen demand. You'd be moving from 114 million tons all the way down to 68.4. So this is a huge, huge reduction in global supply and demand. If you were to look at this with a yield increase, so a 2% annual yield growth, which would be roughly 5 bushels an acre, depending on what your current yield targets are, you would see that over time that nitrogen demand would still increase, right? Because we would be producing more corn, so that's going to scale, or more of these other crops, that's going to scale over time with that NUE value. So even if we're being more efficient, if we're still increasing yields, it's going to continue to drive that nitrogen demand up. And what you would actually see, even at a 0.6 NUE by year 10 of having that NUE and continue to have annual yield growth, you would actually see an increase overall in total nitrogen demand, right? So there is still a scenario where even more efficiency can create more nitrogen demand if we continue to grow yield and improve genetics. So what would this do to prices? And I'm going to be honest, I did not do this analysis here. I asked ChatGPT to help me out with this. And I think it's kind of an interesting way to use AI is to do a lot of this market research, right? But what ChatGPT suggests, and I think it's, after reading through it, I can see the rationale for this, is that you would have price changes and reductions if you're looking at just corn only, based on the nitrogen demand decrease with better NUEs of up to negative 16%, right? So this could really actually drive some changes in actual nitrogen price across the international markets. And if you were to apply this to all crops, because there is so much nitrogen that's applied to other crops beyond corn, you would get to between a 31 and an 80% price change, right? So this is fairly significant. Now, what I want to call out here is I really don't think that price change is simply going to be something that is fully absorbed by the farmer and not invested in other places. What we really see being the opportunity here with reducing nitrogen expenditures is likely diverting attention to the other areas of production that are yield limiters. Our technology at its core is really good at determining whether or not nitrogen is your yield limiting factor. Right now, it doesn't do a great job of telling you what that yield limiting factor is if it's not nitrogen. But we really think that once nitrogen is determined to not be the yield limiting factor and we decide not to put as much on, the attention is going to go to how can we improve production in other ways. What I think that turns into is increased attention to micros and other limiting macros. So P, K, sulfur all come into the lens, as well as boron, molybdenum, some of these other micronutrients, right, that can actually push yield potential higher. The interesting thing about this is that as that yield potential increases in the field, I actually think that that requires more nitrogen as well, right? So they have to work in concert, and what you may actually see if we were to increase nitrogen use efficiency across the board is eventually an increase in nitrogen demand as a result of higher yield potential with folks that are investing more in the things that can drive that yield potential. So that's really what I think is the most likely scenario if we were to think about a hypothetical world where everyone was able to move to a 0.6 or 0.7 NUE. We do believe that's possible. There's a lot of data out there from our data set that shows that 0.6 to 0.7 consistently is very achievable. That obviously depends a lot on your soil types, and James will get a lot more into that in our performance review. There are also a couple other factors that I think are important in this sort of analysis. Commodity price drivers are also very significant. I think we all understand that prices are in a tough position right now, and we need new markets, better markets, right? And so I think understanding and forecasting out where those markets are going to come from is a very important part of this analysis. I also want to bring up the idea of attributes for grain, right? And where are we going to be able to start leveraging some of these other attributes about the way that grain and other produce is produced in the field to start gaining better prices and opening up new markets. So that could also be a potential macro factor here. And then I also, as I was thinking about this, wondered, okay, is this actually going to open up more intensive cropping systems? Are people going to think about how we can fit more crops into a single year, how we can fit more crops into a single field? How does this change the way that people think about it? Again, if they're spending less money on nitrogen, is there another way to invest to make things more intensive? So I just thought that was kind of an interesting question, an analysis that was interesting to do as well. So getting beyond that and into what Sentinel's role is within this overall nitrogen management system, what we are starting to center around is this idea of agile agronomy. And so this idea of agile agronomy comes from agile process management and agile product management, where you're basically using data and consistent feedback to consistently change the decisions that you're making and the trajectory of a project that you're working on to fit your current conditions. A lot of software companies use an agile process in their development where they're stopping every week or 2 weeks to look at what they've done, where they're at, getting feedback, and kind of changing course. In a lot of ways, we feel like that's how nitrogen and agronomy should be managed, and I think a lot of you in this room do as well. Anybody that's focused on in-season management is really at their core using an agile process to inform that in-season management. So we are very committed to using these real-time insights and adjusting inputs to get to the ideal outcome. As a reflection of that commitment to agile agronomy, what you may notice is that we've changed our brand and our name here over the course of the last 8 months. This time last year, if you were sitting in this room, you would have seen Sentinel Fertigation on pretty much everything. We're now Sentinel Ag. The reason for this is that it really reflects our broader commitment to building the future of agile agronomy. Nitrogen is very core to our business, but we're also starting to invest in irrigation and soil moisture management as aligned concerns here. With this rebrand, we've shifted from the shield to the Sentinel helmet, and the reason for this is that it really reflects a focus on decision making because the helmet is worn on the head, right? So it immediately draws attention to the head where decisions are made. And we also have included a positive trend line on that helmet that emphasizes our use of trending and time series data, right, to make decisions and ultimately land on our final point, which is shown in the top right-hand corner of the helmet, that actually looks like a bullseye because it is the optimal target and indicates optimal decision making, right? So that's what's gone into this logo and why we've decided to choose it for this rebrand of Sentinel Ag. We've also decided to change the name of our platform to just the Sentinel platform. The reason for this is we heard a lot of growers and CSPs saying that they were logging into their Sentinel, and we figured, well, we might as well just lean into that and say it's just the Sentinel platform. So you can go and log into your Sentinel as much as you want. InTime is now the brand for our insights engine within the platform. So we're not totally doing away with InTime. It's just now a sub-feature within this broader platform. For those of you that are new to the platform, it is now located at grow info.sentinelag.tech. So that's the address that you can use in your URL to go and find that. If you go there today and you're new to it, you'll see a registration page pop up there. You can create an account. For those of you that are used to using the old URL, you don't have to worry about anything. It will all be redirected to the new URL for you. Similarly, sentinelag.tech is now our domain. So why do we believe that Sentinel is special and worth working with? We believe we're not just another software. We actually are building an agronomy framework that's just enabled by software. So we see software as more of a means to an end rather than the end in and of itself. We have real people. You can meet all of us and talk to all of us here today. The entire team is here, and we do our best to provide real support in real time. Hopefully that's what you felt if you're a customer. And if not, I hope that you'll let us know, because that is something that is very important to us. I also want to acknowledge that we are a startup, and I know that makes a lot of folks in ag a little bit uncomfortable at times. They've seen startups come and go, and that is something that we are intently aware of internally, and we do talk about internally. Our investors are from rural America. We have a lot of investors from here in the state of Nebraska that have invested in this business. We have a lot of investors from the state of South Dakota, from Iowa, from Tennessee, from areas that are agricultural regions in the U.S. We do not have coastal institutional investors in this business. And I'm not saying there's anything wrong with those coastal institutional investors, but a lot of them simply just do not get the timelines that ag operates on. And I think they can create a lot of pressure that moves things a little bit too fast versus being very customer centric. And so I want y'all to understand that while we are a startup, we do have folks that are invested in us who understand ag and are committed to improving ag. We also have folks on our board of directors that understand ag, have been in ag, and are committed to making sure that our customers are first and foremost in any decision that we make. The last thing I'll highlight is our engineers are connected to our customers. This has been another core issue with a lot of ag tech startups, is their engineers are located in California or in Boston, and they've never been on a farm. Our two software engineers, and Josh Hansen as well, who's our software intern, they've all grown up in rural communities. Riley Elwanger, who's our senior software engineer, is currently located in Creighton, Nebraska. Chandler Folkers is located in Aurora, Nebraska. Both of them have family that farm. And then Josh Hansen is actually the son of one of our investors, who is Ag Ventures Alliance out there in Mason City, Iowa. So he grew up in a very agricultural community there as well. So our engineers really are connected, not just to our customers, but also to the communities that y'all operate in. And I think that's very important to how they build our product. We have our Sentry Network of certified service providers who are really the core way that we serve our customers. We believe that local support is really important to farmers having success with the platform. We now have CSPs that represent us in 9 states. The CSPs have been trained in our platform and are continually trained in our platform. Many of them are here today, so if you're looking to get connected with a CSP, we would love to do that. And they are backed up by a Sentinel account manager. So there's a layer of Sentinel that is right there behind the CSP at all times. Our CSPs serve agronomy needs in season. This is one of the core things that we make sure those CSPs do. They obviously, if they're using our platform, are leveraging data for agronomic decisions. They're focused on farm profitability, and ultimately they do align with natural resources stewardship as well. So those are all key things that you will get with each of our CSPs. All right, so now I want to talk about our product, right, and what we actually do and the value that we provide. And a lot of you are probably wondering, what in the world is this picture that is up on the screen when we're getting ready to talk about product? I played football in college, played at Harvard. It was a tremendous experience. I'm originally from Southeast Alabama, and that's basically the only reason that I got out. I thought that I wanted to go to Troy or Auburn and maybe play in the SEC, and had an offer to go to Harvard. Took the opportunity, and it was a great experience. The reason why I bring this up is I think there are a lot of relationships between football and the way that nitrogen is managed, and really the way that agriculture works as a whole. Agriculture is highly seasonal, and I'm going to get into why I think football and nitrogen management are related. The reason why I'm throwing these pictures up here on the screen is this is actually the play sheet that we went into the very last football game that I played at Harvard with. This was a game against Yale in Fenway Park, and this is still sitting at home. It's basically our script going into the game. So if you see here what's highlighted on this left hash, right hash, those two subheadings there are drive number 1 and drive number 2. So we had literally plays scripted out for the first few drives of the game formations, motions, play calls, all the different details were all put out right here going into the game. We knew exactly what we were going to run, and then we were going to basically read and react to what the defense gave us to change to our second half formations, maybe pull in a different second half formation, right? And we ended up winning this game, so the game plan was pretty good. It was a 45-27 victory, and it was a great way to end that season. Nitrogen management is very much the same way. You go into the season with a plan, you prepare that plan, you have an idea of kind of the growth stages that you want to apply nitrogen, you have an idea of the rate that you want to apply at those individual growth stages, you have a good idea of the products that you want to use or have access to, and so this is really a plan that's created. It's kind of your script, right? For that very first drive of the game, you're going to start the season with that plan. The thing is, weather's always going to throw curveballs. You might not plant at the same time that you expected to. You might have trouble getting into the field for whatever reason and be late on a nitrogen application. So what does that do to what your nitrogen plan needs to be? Maybe you have more yield potential than what you expected, right? So you've got to read and react to what the season is giving you. And with that, you've got to make adjustments, right? You have to figure out, how do I change my timing? How do I change my rates? Potentially, how do I change my source to align with what the crop needs? And then ultimately, the goal is to deliver very good results. You want them to be profitable, you want them to be efficient, and you want them to be productive as well. So all of those are why I think football is it's a great allegory for nitrogen management. What makes Sentinel different in terms of how we're addressing nitrogen management is we're really trying to lower the user input that goes into a technology to manage nitrogen while simultaneously getting the advantages of a very detailed and complex system. So we're constantly balancing these trade-offs between accuracy and performance of the product with the amount of time and input that comes from the user. We are, to my knowledge, the only solution on the market that combines all these factors that I'm showing here on the screen: near daily insights, having a low barrier to entry to get started, not requiring a yield goal, which is a key component of our approach. We really don't want to use a yield goal. We want to play to yield potential. We don't require labor in the field. That doesn't mean you don't have to do anything in the field. You're still going to be applying fertilizer, but the reality is we're not using labor to go out and collect data in the field. You're not collecting tissue samples or soil samples. We do not actually require historical data, so you don't have to go in and put historical yield into the platform, historical nitrogen applications to make this work. It's all current data. We're able to measure nitrogen credits in real time, detect demand before it is visible in the field. We're able to provide full field insights at very high resolution to allow for site specificity. And the way that we've designed our technology is able to actually hone in on specific hybrid and variety needs in the field. We've developed 4 different product tiers to serve different needs for our customers. Each of these product tiers comes with a 12-month subscription, and they are charged on a per acre basis. Our Sentinel Standard tier is a new one that we're introducing this year. This basically leverages a coarser resolution and lower frequency imaging to provide simplified nitrogen management for dryland row crops. We know in most cases on dry land, you're not going to be making multiple in-season applications, and if you are, they're more going to be timed around when you're able to detect that there has been a change in the field. And so we believe that reducing that image frequency and getting to a little bit lower resolution is better fit for those dry land row crops. We also are introducing Sentinel Irrigation this year, which is built for standalone irrigation insights for row crops. Obviously, soybeans and crops like that don't typically get nitrogen, but we do believe that they need better irrigation management, and so this tier is really geared for those crops that may not be getting significant applications of nitrogen or need nitrogen insights, but still would like to have better irrigation insights. Sentinel Advanced is now what we're calling the tier that most of you are familiar with. This is our most popular tier, and this is really precision nitrogen management for pivotal decisions. So this is for your intensive dryland managers. This is for your irrigated and fertigated nitrogen managers. This is going to be near daily satellite imagery at 3 meter per pixel resolution and the insights that you are accustomed to seeing in the Sentinel platform. And lastly, we have our Sentinel Complete, which basically combines Sentinel Irrigation and Sentinel Advanced into a complete tier that serves integrated nitrogen and irrigation management. So that'll include our in-time insights, our all-in advisor, and our HydroFlow insights as well. So that is our product lineup. To get into some of those individual features, we have our in-time insights, which some of you may be familiar with. This is really that read step within the nitrogen management philosophy that I laid out for you earlier. What we are doing here is we're basically using near daily measurements of satellite imagery to track crop nitrogen sufficiency over time. It's very similar to the concept that is behind a soil moisture probe, where you're essentially trying to keep moisture in an optimal range for the crop. So our whole goal is to keep sufficiency within this green zone, which basically is where you're at the highest likelihood of maximizing your profitability, right? So that is the whole goal. What we are able to do is also detect when we have an approaching deficiency and when we actually have a deficiency out in the field, which are these yellow and red zones on this image. And I want to highlight this image because each one of these black lines is an individual application of nitrogen, and you can see after each one of those applications that there is a positive response in that sufficiency index, which indicates that we are actually picking up on nitrogen applications. What is also pretty cool, and we won't have an opportunity to show today, but maybe they can show you at the product table, as we've integrated Nave's insights, Nave Analytics insights for soil moisture tracking and leaching risk. This field that we detected this nitrogen need on once we had enough biomass in the field with optical imagery at this point, basically in mid-June, they had similarly detected that there was a high likelihood of nitrogen leaching on this field leading up to this point, right? So this is a very capable tool for detecting sufficiency needs and informing application timing. The reason why we believe that we're able to actually provide good nitrogen insights with remote sensing data, which at times has been criticized for not being specific enough to a particular agronomic factor in the field, is that we implement what we call Sentinel plots to calibrate every satellite image that comes into the system. These Sentinel plots consist of a nitrogen-rich area, which is this green plot in the field. So this green plot right here would have more nitrogen on it than the rest of the field. The red plot, which is a canary plot, we call it, or a nitrogen poor plot, that is going to have less nitrogen than the rest of the field. By doing this in multiple locations in the field, we can actually get a 3-point calibration and see crop response to nitrogen in the reflectance. This makes us confident that we're actually seeing the differences caused by nitrogen and not by some other factor like stress from pests or disease or water. And it also helps us to see what is the crop's potential with additional nitrogen and to see nitrogen demand before it occurs in the bulk part of the field, because we're using this low nitrogen plot to be an early warning indicator. That's why we call it a canary for nitrogen stress in the field. Putting these Sentinel plots in has been a challenge in the past, and we have sought to continually make this easier by making our prescription tools easier, by making sure that they're sized appropriately to make sure that equipment will intersect these plots at some point in the field. We do have some different features that we've added to the platform, like being able to auto-place these plots based on management zones, and even implementing image-based zones that are automatic and created for you when a field is uploaded into the platform. We've also added a lot of features to allow you to confirm the plot location, make sure that they're accurate, and we're also validating these plots now against a virtual SI, so that if you are unable to get plots in the field or you're unsure about where they were located, we can still use other information to help make sure that we're tracking that sufficiency accurately. We've also introduced our All-In Advisor tool, and this is kind of that adjust stage within our nitrogen management philosophy, because this tool allows you to adjust your rates and spatially adjust those rates as well, so not just at a full field basis, but site specifically to the actual needs of the crop. This particular feature brings in historical and forecasted weather scenarios. So we're actually pulling in 10 years of previous weather history, as well as a 14-day, an extended, and a seasonal forecast. And what we are enabling with this is to see how precipitation might impact uptake, how different weather factors like photosynthetically active radiation is going to change the way that crop develops. And it also gives you the ability to assess potential ROI from each application. The rates that we recommend are really focused on balancing trade-offs, right? Nitrogen management and really farming in general is all about balancing trade-offs. We wanted to incorporate that concept within the All-In Advisor, and we actually incorporate 5 key nitrogen stewardship metrics into this rate and trade-off balancing approach. You can see here in the image on the left-hand side of your screen, I know it might be a little bit small, but there are basically different rates recommended for each one of these different weather scenarios, and you're able to rank each one of those different metrics by the different factors that are going into balancing that trade-off. Your CSPs have been educated and taught and will continue to be educated and taught how to interpret this and make those recommendations to you. So as a grower, you're ultimately going to get the same simple output, which is a rate recommendation and whether or not you need to apply nitrogen. But I wanted to show you this because this is on the back end, what is going in to making sure that these rates are correct. We also have enabled abilities to manage complexity at scale. We've improved our dashboards, we've improved our notifications, and we are regenerating these recommendations with prescriptions daily so that they're ready to go as soon as you need them and need to get into the field. Some of the use cases that we've seen with this technology are fertigation and spoon feeding. This is our most common approach, but we've also started to see that side dress timing, rate, and placement are key things. We're working towards product, and some folks are thinking about how can we use the system to at least see how a product worked, how quickly did that nitrogen make it into the crop. We've been looking at additional application justification. So for those of you who think about a rescue application, potentially this is something that we have seen a use case for, of can we detect that we actually need rescue on this particular field. And we've also seen folks use this to assess different products and practices. If they're trying cover crops, if they're implementing biologicals, any of these new products and practices, this technology can actually be used to help manage those and actually see what the results are before you make it all the way to yield. I also am happy to announce today that we have partnered with NAVE. This happened officially in December of this year. And what this is basically allowing us to do is integrate nitrogen and water management into a single platform. We know that folks are tired of switching between different platforms, and we believe that these are common enough needs for folks that we want to bring it together into one platform. So we're really excited about what that will do for us. And what that is going to enable is our HydroFlow insights. These HydroFlow insights are going to be found in Sentinel Irrigation and Sentinel Complete. They're powered by NAVE Analytics. And what they allow is probeless soil moisture and crop water use insights. So there's no hardware deployment to have to get some of these irrigation insights into the platform. It captures spatial variability in soil moisture and crop water use so that you're able to actually see how different areas of the field are responding to water at different points in time. It provides guaranteed daily insights, right? So one of the biggest limitations for remote sensing is, are we able to get around the clouds that sometimes impede capture? For us, that's been a big struggle with optical imagery, but because they use a cloud penetrating data source, they're able to guarantee a daily insight, and we're excited to work with them towards actually improving this within the nitrogen side of our platform as well. What they've seen in their validation is a 93% alignment with soil moisture probes, and this gives you an idea of how that data looks. It is basically a field level soil water content graph, right? That's very similar to what you would get with a probe, as well as a virtual soil moisture probe. Our long-term vision here as we continue to integrate data into the platform is that we could also pull soil moisture probe data in and actually calibrate this remote sensing data with those actual in-field measurements to produce very accurate outcomes. I want to talk about a few of the projects that we're doing to adapt for scale. We are introducing for our CSPs this year the ability to use a virtual sufficiency index. We are not quite ready for this to go out fully commercially. We've done some testing, but all of our CSPs are going to have access to this year so that they're able to see this and see how well it is performing and if it's meeting their standards of performance. So that is something that's coming. This basically will allow us to manage sufficiency without putting plots into the field. So if you're in a situation where it's hard to get plots in the field or you're unable to get plots in the field to calibrate images, this is going to be a tool that will be at your disposal hopefully in 2027 with a full commercial release. But you can see these orange lines are our virtual sufficiency index. These blue lines are the actual plot-based sufficiency index. We're really doing a good job of capturing trends, and now we're just trying to tease out how close can we get numerically without having these plots in the field. We've also developed tools for automated proof of placement, so being able to automatically process as applied data and verify the location of plots at different rates that are put into the field. And we have developed technology for image-based zones, so that as soon as you import a field boundary, we can automatically generate these image-based zones that can be used to inform your management on a field. On top of all of this, it's all kind of being integrated into an SBIR project. So this is a small business innovation and research grant that Sentinel has received that is working towards a guaranteed availability nitrogen decision support system. I mentioned a minute ago that remote sensing information is often impeded by clouds. That's one of the biggest struggles that we have. We've received funding from the USDA and a phase 1 grant to work alongside NAVE to build out this guaranteed availability decision support system. This will start to incorporate cloud penetrating remote sensing information into our nitrogen modeling approach so that we can produce a sufficiency index every single day. We do believe that that is something that you should be able to have as a customer. There's no reason we can't do it. And so we are going to achieve this through model forcing, through integrating seasonal weather forecasting, and ultimately building a field-specific nitrogen model that can be continuously trained and calibrated and specific to your field's particular conditions. So one thing I haven't talked about a whole lot yet, except for my mention of ChatGPT earlier, is where is the AI hype? You may have seen a lot of other companies talking about how they have all these AI-enabled features, and they're doing everything with AI. Frankly, our engineering team is not very gung-ho on AI, and I'm not either at this point. I don't think that it can really be used to drive decision-making at this point. It just hasn't been developed and trained well enough to inform actual decisions. Where we do see some of the AI hype impacting Sentinel is, number one, voice commands and report generation. We think there is a very real opportunity to give you the ability to talk to your Sentinel app. So if you maybe make an application on several fields, what we want to give you the ability to do is talk into the Sentinel app, say I applied X amount of pounds of nitrogen on these fields on this particular date, and have that automatically logged in the Sentinel platform. We understand that logging applications and irrigation events is challenging. We want to work towards this to make sure that it's meeting you where you are and that we're making it as easy as possible to get this information into the platform. Support tools are another thing that we think AI can be used for. This is not a decision, but it is facilitating something that we can do as humans, but it just takes more time for us to do. A great example of this is a fertilizer blend calculation tool. Right? So we are looking at how can we use AI to facilitate more of these sorts of inputs into our platform. The last thing, and this is actually where we're currently using AI internally, is data processing and quality control. So when we get satellite images into the platform, we actually run them through an AI engine that detects whether or not we have clouds or shadows that are impeding the quality of that image, right? This is something that AI is very good at. We have enough data to train it on. We are currently investing in building out this engine even further because we want to make sure that not only are we detecting whether an image is good, but if an image does get through, can we correct the zones that we're generating off of that image? Because if we do have a cloud or a shadow somewhere, it will impact how those zones are made, right? So we want to continue investing in this so that we're able to correct for that. We do have some opportunities in 2026 that I want to make you aware of. We are currently working with Nebraska Department of Water, Energy, and the Environment on a nitrogen practices program that we hope to have fully released here over the next couple of months. But what this will be is an adoption incentive program that's really focused on practices rather than just on a rote outcome. So this is going to be much more fit to where you are in your operation and encouraging better practices rather than just reducing by a certain amount of nitrogen. This is going to be for sensor and model-based in-season nitrogen management. We also have partnered with Practical Farmers of Iowa to enable on-farm trials in Iowa, Illinois, Minnesota, Wisconsin, Nebraska, and Missouri. These are non-fertigated trials, so this seeks to basically prove out our rain-fed technology. They will be compensating producers that cooperate with $1,000 for participating in the trial. Spots are limited, so if you have folks that are interested in doing that, please make them aware of this opportunity. When I say Nebraska and some of these surrounding states around Iowa, they're really looking at those border regions, right? So this is going to be really tailored towards eastern Nebraska, northern Missouri, your western Illinois, and your southern Minnesota and Wisconsin, right? So they're looking mostly at borders. If you have somebody that you think would be interested, I'm definitely happy to connect them with PFI and see what their interest is in participating outside of those regions. We also have submitted a grant in Minnesota to fund some on-farm trials and on-site trials for nitrogen management in corn. This is with Minnesota Corn. We do hope to hear back on that in mid-February, so that there's still time to get folks signed up. We have other opportunities beyond this that are available, so if you don't see something here that is of interest to you, please come and talk to one of the Sentinel team members today, and we'll try to find something that is better aligned with your interests. As we head into Bob's presentation, I just want to highlight that there are ancillary benefits to optimal nitrogen management. I'm not going to speak towards this a whole lot because I didn't double check with Bob too much before I built this presentation, so I won't hit on this a lot, but I am excited to hear what Bob has to say about the other benefits that we see to optimal nitrogen management. And I want to pretty much end on our vision for nitrogen stewardship. We believe that informed in-season application with limited pre-plant nitrogen is really the future of nitrogen management. We think policy is moving this direction. We've already seen indications of this by NRDs in Nebraska to restrict nitrogen applications prior to May 1st, right? This is going to come. It's a matter of time, not a matter of if. So we are committed to this vision of nitrogen stewardship. What this is going to require is the availability of in-season application equipment. I don't believe that there is a one-size-fits-all approach to in-season application. Everybody's going to have a different way of getting it done. It's going to be fit to your terrain. It's going to be fit to your products. It's going to be fit to who you have locally that's able to provide these services. But this is going to be everything from high clearance machines to fertigation units to pivot telemetry and control, drones, airplanes, maybe even robots. There are companies that are working on trying to have road driving robots to be able to do this in season. I think they're going to have a heck of a hard time figuring out how to do that and making it through all sorts of different terrain, but people are really looking at how do we enable this in-season application. It's also going to require readily available liquid fertilizer or foliar formulations, right? We're going to have something that can get into the plant immediately to be able to address any concerns that we have quickly. It's going to require functional soil practices because our soils are going to have to be resilient in the cases where we can't get into those soils as quickly as we would like, right? So we're going to have to make sure that we have a little bit of buffer room to do this well and give us time to respond. And I also think that we're going to start using nitrogen to control plant development. There's already a lot of conversation about this in the cotton industry of can we use nitrogen to actually limit the growth of a crop and make sure that we don't have to put plant growth regulators on that crop. I think you're going to see very similar things start to happen in corn where we're looking at how does nitrogen impact plant hormones, right? And how can we start to manipulate and control these crops a little bit more with nitrogen. So this is the vision that we have for where nitrogen stewardship is going. And with that, I want to wrap up this welcome. I know I'm a little bit over time here. I want to make sure that Bob has plenty of time to present on nitrogen agronomy. So I appreciate y'all listening to me. And Bob, I'd love to invite you to the stage.